Can you see my screen? Yes, no?
Yes, sir. Yes, sir.
Okay. Just give me a second. Let me just keep it here. Smaller window. I don't know. There's be surprises, but let's see. Okay, so the first thing that I want to show you today, where did this disappear? Just give me a second. Where are my windows disappearing? Just give me a second. This is my windows. These are my command windows. Oops. Oh. Okay. So I first want to introduce you to a tool called Wireshark. Wirishark. Okay. So this is a tool called Wireshark. So you will not understand many things in this tool now. But I just want to introduce in the first class. You will not need it for your assignments right now. But this is a fun tool which basically captures everything that goes in and out of your computer over the network, if you can configure it properly. Okay. So as we learn new and new protocols, you will be able to actually see in action many of these things happening, what packets go in and so on. And there will be a lot of surprises also. Most part of it or quite a bit of it you will not understand now. Okay, but I'll just demonstrate something very small to show you. So this file edit, all these things, and this capture window, there's a lot of documentation. Okay, capture is basically says to capture. Okay, and this capture filter says what do you want to capture. You can put filters to say, because normally there are just too many packets. We'll do that today, just capture everything. Okay, but then you can actually capture, put filters to say I just want to see the TCP packets, I just want to see the DNS packets, if you're that kind of, so it's not just a fun tool, but if you want to debug network problems happening to your machine and all beyond configuration and so on, large distributed system where lots of machines are communicating and so on. Okay, the first thing that people ask you to debug network problems, you're going to say that run this and send me the capture. But they want to see what has been put on the where, what packets, somebody was supposed to send a packet, whether that was sent or not, was the response received or not, what was the format, what was the content. Okay, so it's a very important debugging tool also. So this is what my filter looks like right now. Okay, so out of many different things, okay, let me see the options. So you see the options shows you what are the things that you can capture. Okay, and you see there are lots of this local area connection 8, 9, 10, etc. Does it mean my machine has so many cards? No. So that's why I said many things you will not understand. There are some local emulators and so on. But this Ethernet is my LAN connection, the wired connection that I'm using. And there's a Wi-Fi, which is my Wi-Fi connection. So I choose this. You can also choose many different for this now. You can say whether you want to, where do you want to create the file and so on. And then many other options that will come up. Just not to worry about the first class. So I'm basically saying I want to capture my Ethernet. Okay. So I go to capture, I go on start. I had already something, so it says, do you want to save the older capture? I say no. So you see there's lots of things happening. I've done nothing in my machine. Okay. Because in the back end, let me stop the capture. In the back end, there is lots of things keep on happening, even if you feel that your machine is not doing anything. We'll look at one or two of them, okay? But there's a lot of things, and you see there's a UDP protocol, there's an RTCP protocol, and all those things. So if I take this UDP protocol, okay, you can read this. Yes, no?
Yes, sir.
Okay. So you see it says gives a frame number, says this has put 188 bytes on the wire, okay? 188 bytes captured or captured from the wire. This is the interface. This is nothing but the Ethernet address. The protocol is Ethernet 2. I want you to remember this a bit. Okay, we'll come to this later. Source is this, the Dell card. Destination is this. Okay, this is basically the switch. Okay, and it is using a user datagram protocol. So it's something that you will not realize. So it's kind of keeps the connection with the switch alive. So it's kind of telling the switch I'm there kind of thing, basically. Okay, so Cisco, this Cisco thing is the switch. Dell, this is the LAN card on my PC. Okay. But let's do something. So out here, so let me stop this capture. Okay, we have not started it yet. So let me start this capture and then quickly come here and click on this. See, it opens IIT Madras website. Okay, let me stop it. But the capture can give quite a bit long. So I have to figure out now where it is. You see so many things, you know, this all these packets have come basically. Okay, this is a number field also, but anyway. So let me look for the one that I want to show you. So this 10.5.17.233 is my machine's IP address. I got it through DHCP. This is the problem, because so many things come. Hmm. 103.158.43. Okay. Is the response. So there has to be a query to 1884. Okay. So you see, the first thing that happened, that I have to resolve this name. Okay. So this is actually AAAA, this is an IPv6 address. There will be one thing before this also. Maybe before or after. Okay, here is the one. Okay. So first thing it did was basically, it is saying that this Ethernet packet carries with it an IPv4 packet, okay, which is carried inside a UDP packet, which is carrying basically, or others, put the other way, the DNS packet carries the UDP packet. So this is that the layering thing we'll talk about later on. This is what at the lowest layer, then something we put header, something put header, put header. And you can see the details of every packet. Okay, all the fields of the IP header, you may not understand what it means now. Okay, but this I think from your general knowledge also you can see. So this is the DNS query that went out for csc.iitm.ac.in, type A, which is a host address. So basically I'm saying that give me the IP address for csc.iitm.ac.in. Okay, and there is no response because this is the query. Okay, this is a standard query. And now if I go down So this one, okay, this is a type AAA response, so there'll be one more. Is the response somewhere? Let me show you the standard query response. So this is the IPv6 address response for the query that went in. There should be an IPv4 response. Oh, here it is. Sorry, it's on the top. So now the same thing is coming back to you. It's a response. This was the query. And see, it says that 103.158.43.116 is the IP address. Okay. It also says who answered it basically. What is the name server of this? Okay. And then there are additional things basically, which says, so this gives me both the DNS server addresses for IIT Madras's DNS server, which told me that csc.iitm.ac.in is address is this one. Basically. So I just wanted to show you this example because DNS is something probably the name to IP mapping, even though you don't know networks, you know that IP addresses are there and names have to be mapped to that. So what I want you to do is to install Wireshark, WIRESHARK on your machines. It works on both Windows and Linux. You will work primarily with Linux and just start fiddling around with it. Okay, look at the documentation. There will be no assignments on Wireshark. Okay, so it's not that you must learn it or anything, but this is something that is fun and very, very useful tool for debugging network problems when you work with a network with lots of machines communicating with each other and so on. Okay, so Wireshark I will end here. Any questions right now? Yes, no?
No, sir.
Okay, okay, silence will be no. Thanks. All right. So let's start with what we are going to do today. So unlike the theory, just give me a second. So this is going to act as my blackboard. Okay. So unlike the theory where we started from bottom up, we started with the very low physical layer, things, the communication layer and so on. Then we said we'll make two machines communicate and so on. Okay. But then, as I said, most of the things are done. You need to understand it if you can want to do it in future and so on. But in lab, we will come from the other side. We'll start knowing the basics and starting to build simple network applications. So applications that can run on multiple PCs. Okay, we'll mostly work with two PCs. I will demonstrate on one PC. You can test on one PC only. But then ideally you should test with some of your friends running it on two PCs as much as possible, at least, because then there is actually a network in the middle. But then you do not know anything about how the stack works, and you don't have to. We'll teach you certain abstractions. Right now, we'll tell you kind of what the properties are, and you will accept them. You will know how to program it and move on. Okay. And many of the things when I explain, I'll say put a 0 in there right now. Okay, don't worry about what this is. Take it as a black box. Okay. Because we'll come and cover each of those things, and then when we come back to the original layers, primarily TCP, okay, we'll actually kind of tie up what you learned here with the theory out there, basically. But right now, certain things you will take as a black box and program. So the thing that you need to know is a socket. So what is a socket? So socket is basically an abstraction. Okay? So this is your machine, okay, and it has lots of things. This is another machine. There's lots of things, and there is a network connecting them. Okay, a socket is kind of a hole in here and a hole in here. Okay, so you don't care. It's like a black box. It abstracts out the entire details of everything out here. Okay, you want to drop your data out here, and you want to get the data out there. And same way, the other way. In one socket, you can communicate both ways. All right. So that's the abstraction. Now there are different types of sockets that we'll see, and based on the type of socket that you are using, it's going to give you different properties. So the two types of sockets we'll talk about is a TCP socket first and a UDP socket. Okay. So what's a TCP socket? Basically, we'll see how to use it. First of all, it says it's a reliable. That means if you put something out there, if you put an X out there, it will eventually pop out here. You don't get lost. How that happens, don't worry. We saw that there is noise and so many things, etc., that can corrupt the data. We'll see more sources of error later on. But TCP protocol will somehow guarantee you that whatever you put in here will come out of it. Okay, so that it guarantees reliability. Second thing it guarantees is in-order delivery. That means if you put X first, then Y, X will come out first, Y will come out next. Why things can go out of order? Again, we'll see when we do the theory as to how a packet exactly goes across a network. Slowly. But TCP will guarantee you don't have to worry about all that. That if I want to put put X first and then Y, then somebody, whoever the destination is, receiving it will first get X and then Y. There is no chance that it will get Y first and then X. Okay. And this is a little bit kind of, this is called byte oriented. Okay. What is byte oriented? So basically, TCP looks at your data not in like 4-byte chunks or 8-byte chunks or something. It just sees that you send a sequence of bytes and is delivering a sequence of bytes. Okay, so this has important ramifications of how this transfer goes in. But to TCP does not try to make meaning out of data in any way. Okay, when you use a TCP socket, the socket looks at it like you have sent a sequence of bytes into it, and it will give you that sequence of bytes in the same order at the other end, guaranteed. Okay. So you will not try to say, oh, these 4 bytes are carrying integer, or these 8 bytes are a packet. Nothing. Okay. As opposed to that, UDP is unreliable. It does not give you any guarantee. Okay, unreliable, yeah, in the sense that sometimes it will go, sometimes it may get lost. No guarantees. So it's the application to decide whether you want to use UDP or not. Okay. A classic example is the DNS thing that I just showed you. Okay, you say www.google.com, you send it to your DNS server gives back a response. This is a typical place where UDP is used because UDP is fast. Okay, and there is some other reasons I will discuss later. So in this case, when I send the query to the DNS saying give me the IP address of www.google.com, it is highly possible that my query does not reach the DNS server or the response does not reach me. So UDP does not guarantee me anything. But then what will I do as a DNS client? I'll just wait for some time, and if I don't get the response, I'll query again. The chance that I will fail again and again and again is very low. But this is a type of application that can tolerate failures, tolerate unreliable delivery, because you don't change anything. You're asking, if you ask twice, what will happen? Maybe the other one will come later. It is actually not lost. It was just slow in network somewhere. But that's okay. You did not change anything. Okay, unlike sending a command to say put x equal to x plus 1, because that you cannot do twice. Okay. It is unreliable, doesn't guarantee this. This may be out of order, no guarantees. And this is the other, this is a message oriented protocol. Again, give me some time, I'll explain what it is. So this now says, I don't look at it as stream of bytes. Okay, I look at message. Okay, so whatever you gave me in one go, I'll pop it up here in one go. So if you gave me 10 bytes in one go, I'll send 10 bytes in one go. If you gave me 20 bytes in one go, I'll pop out 20 bytes in one go. If you don't read the 20 bytes, the remaining part will be lost. We'll look at all of these things in detail with actual calls. But TCP's difference is you give TCP 100 bytes, TCP will give you 2 bytes now, then 4 bytes, then 90 bytes, then 2 bytes again, and so on. It doesn't say anything that I will give you the 100 bytes together. It just says that if you keep on reading, I will give you the 100 bytes in that order in which you sent it. Is it okay so far? Any questions? I don't like slides for these things, okay? Because I will give you enough material. There's enough material that you can read anyway. But let's try to understand these things. Is it clear?
Yes, sir, it's clear.
Okay.
Yes, sir.
Okay. So then, let's start with TCP sockets. Programming with TCP sockets. Okay. So you see the sender is one machine, receiver is one machine. So it's obvious both of them have to do something. I cannot write anything here to open the socket here. So that will require a network connection itself. So it's a recursive. Okay. So to communicate, both parties must do something. All right. And what is it that you need to do? So think about this one. Think about a very simple example that I will just send a string to this side and this side will print it. That's it. Okay. Then this side can send me a reply, yes, no, I printed it, whatever else. Just a simple message transfer. Okay. So we use the term TCP server and TCP client. Now, client and server are very intuitive terms. Okay, it's the idea of who is providing the service. We say DNS server and DNS client because I ask the DNS server to provide me the service of name to IP map. Okay. In real world, you decide like that. There is no sacrosanct technological definition of this is a server, this is a client. Okay. Whoever is providing the service for the application, but one of them has to be server, one of the client, because the programming is different. The server, the client connects. If the client wants to act as a server, something else has to be done. Okay. So the thing is, server basically waits for client. Client, and I highlight them for a reason, asks for service. So this is the model. Because see, because it wants to wait, I have to do something extra here and something different. Asking is different than wait. Okay. And this is what is called, we'll hear this term a lot, client server programming. All right. Okay. So we'll start with the TCP server. Okay. First of all, you have to create the socket. Okay. There is nothing. You want to communicate, you have to tell the system I want to communicate. So first step is create socket. And this is done by a call called the socket. We'll see what the parameters are. Okay. Then it says bind the socket. What is bind doing? We'll see actual code and everything. So today's class, I'm telling you again, is going to be a little long, but bear with me, okay? And try to concentrate. So binding the socket basically says, see, this DNS server, how did I know where is the DNS server? Okay. Secondly, how did I know, out of See, I may have a server which runs a DNS server, telnet server, DHCP server, many things in one machine. So when a packet comes, okay, how does the packet, the OS know which of these things? Should it go to the telnet server? Should it go to the FTP server? Should it go to the DNS server? The DNS server's packet should go to DNS server. Telnet server's packet should go to telnet server. And so on. Okay. So there are two things that distinguishes this one application to which packets are tested. One is, so basically you specify an IP address and port. So it says basically that is telling the system that if any packet comes looking for this IP address, this port, give it to me. So if this is the DNS server telling it, telnet server will say, if this comes from any IP address port, give it to me. Now IP address is for the machine. Actually, it's not even for the machine, we'll see, but let's just assume simple machine. Okay. So between your DNS server, telnet server, FTP server, what will differ is this port. So that is how the system knows. It looks at the incoming packet. It says this the IP address is the same for all of them. It's a simple machine. One machine, one IP address. That's what you have seen normally. Okay. So this basically says that if it comes for port 80, give it to HTTP server. If it comes for port 21, give it to telnet server. And that information about the port is inside the packet. The packet is telling the OS. We look at headers and everything and so on. Okay. So it has to tell which is the port this thing whose data should come to the socket. It's bind. Then there is a call called listen. Very simple call. I will just write configure queue. Okay. We'll see what this is. It's a very simple call. And then you wait. Wait for client. Okay. Which is basically accept call. Okay. Then read. We'll do the receive call. Right. Or let's not use the word read, right? Receive from client. You may not have to do both of them. Okay. Send to client is send call. Okay. This depends on application. I may do multiple receives first, then one send. I may do a send immediately, then receive. I may not do any receives. Okay. Anymore. For example, for this DNS thing, basically you will receive and then send. The DNS is UDP. So this is the sequence of things that will happen when you write a TCP server. You will write a socket, bind, listen, accept, receive, send. Okay. What about the TCP client on the other side? Okay. Everyone has to create a socket. So we'll make the socket call. Okay. But the client doesn't need to bind, because moment you can, okay, there's no harm in this, but we normally do not do. Because when the client will connect to the server, the local machine, the client's machine already knows, okay, the IP address. And the port number, it will assign arbitrarily, send it to the client. So client does not bind. Okay. See, the client does not bind. Think about the reason. Okay. Client does not bind because, see, a DNS server, everybody needs to know. All the machines in CSC needs to know that the CSC machine DNS server is running at ports such and such. Okay, so the port has to be a public thing that everybody knows. Therefore, it has to be fixed. But my machine is a client. Okay, the port that it goes out through in the socket, okay, is unimportant. Okay, but okay, well, I'll come back to it. So no bind. Okay. But this is true for server socket both. Every socket has an IP port. It is just that because this one nobody external will want to connect to it, okay, this port will be assigned dynamically by the system. Again, let's not worry about it now. We'll come back to this. And then it does something simple. It does connect. So connect is where it talks to access. Is the sequence of calls clear? Yes, no?
Yes, sir.
Okay. So again, if you don't understand something, normally in class I can see your faces and I can get a feel, basically. Okay. If you don't understand, please ask. It also helps. See, for every question that you have, from my experience, I'll guarantee you there are 20 other students have the same question. They are just, should I ask kind of thing. So you ask, it helps just not you, everybody else. Okay, so I'll assume it's okay. If not, please tell me. All right, so now we'll go through this, look at these calls one by one, and then look at actual code, run them maybe, and see what happens. So this socket call. So this takes 3 parameters. Okay. So this one, you will always put AF inet. Don't worry about this thing. You can, will show you code and all. AF underscore inet. Okay. Or PF underscore inet. Okay. So this is AF underscore inet or PF underscore inet. So this basically tells that you are using the internet family of sockets. Now, sockets came from, it's called BSD, Berkeley sockets, early 80s. Okay, came out of Berkeley originally, and then it kind of became de facto standards. But then in those days, so right now you will hardly see anything other than inet because it's all internet socket, which is basically your IPv4, IPv6 things. Okay. But old days there were lots of other networks, and there are some, even now there are some local things like AF, Unix and all for local communication and so on. Let's not worry about it. But in the old IBM had their network called SNA. DEC had their network called DECnet and so on. Because there are many other types of networks. So you have to specify which family of things you are using. So right now you will always specify AF inet or PF inet. This one you will specify the type of socket. What is the type? Is TCP or UDP. So for TCP is sock stream. For UDP, it is sock diagram. We'll see. So this is my TCP socket. Okay. And this one right now, you put 0. Yeah, I'll explain to you why later. Do not worry about it. Okay. And if it is successful, it will return you a socket descriptor. Okay. So I should have written it here. So this will be sock FD equal to, you will make this socket call. All right. So this sock FD is now your kind of unique identifier for this socket. If you open another one, you will get another socket. It's just an integer. Okay. When you read OS, read a little bit about file systems and so on. I'll explain to you maybe near the end of the lab. What does this correspond to? Okay. All right. So I got the socket. Next thing I have to do bind. So I have to specify the IP address and port, and that is done through a strange structure. Okay. So the bind calls basically has something like this, and I will check an error always. Now, who do I want to bind? I want to bind the socket, this particular socket. Okay, and then I'll write something strange. Struct sock addr in, and I'll just explain. And then size of struct. No, sorry, not socket addr in, socket addr star. This is ampersand. Struct socket addr. Struct. Okay. I may be slightly wrong here and there, but don't, you can look at it. So what is this thing? This server addr. Okay. So I will declare a variable like this. These things you just have to remember. Okay. Sock addr in server addr. Okay. And then the serv_var. Serv_var is just a variable name. You could have named it anything, just a variable. Okay. And this is a thing that is already defined. You will have to include header files. I'll show you. Okay. So you will say sim family. There are 3 fields. Okay. Is equal to AFINET. You will again say this. Then serv_var dot sim port equal to, for now, let me just put the number. Okay, I'll explain something here. Okay. And then serv_var dot sim_addr dot. So this again is structure. This thing you are just to remember. Okay. Now let me put in for the server in addr in. Okay. And this entire thing, this will be a variable declaration. I'll put before calling the bind. Okay. So the structure thing is just you have to remember. So basically to bind, you're telling the system that this is the address, this is the port to which you bind. So tell it in some form. This is the form in which BSD sockets in C works. Okay. So, but you see, note one thing. I have a sock addr underscore in structure, but then I typecasted to something different. Struct sock addr structure. There is no in out here. Okay, this is a star. So this is an address. Okay. I'll come to that. So this thing I specify 3 things. Again, the family, the AFINET. I specify a port. Okay. You can take any port, but then again, some ports are reserved. So anything, take, when you write your code, anything greater than 10,000 to be safe. Okay. Actually, much, you are safe usually much lower, but just in case, basically 10,000 is just a number I put in. There are actually there is, and this port is 16 bits. Okay. So less than 65,536. You have to choose a number less than 65,536. Okay. And this is what is telling the thing to accept packets from any IP address. Now this is what I said, your local machines all have one IP address. Okay, because IP address is not really associated with your machine. It is associated with your network card. So most modern machines, including many of your laptops with the LAN port, may not have one IP address. Okay, you may have, if you enable both of them, you may have an IP address in a wireless card connected to something, IP address on the LAN card connected to something. Okay. So question is, this particular server, does it want to accept only packets coming from the LAN and not from the Wi-Fi? Only packets coming from the Wi-Fi, not from the LAN, or from anything? If it is only one, you have to specify an exact address. I'll show you how to specify it for the client. Okay. So I did not do it, just wanted to show you something else. So this is basically saying accept packets coming to any IP address of this machine. Basically. But the port number has to match to 20,000. And then I just pass this, just to pass the length of the thing. So is it clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Then listen is a simple call. Listen, you just say sockfd and a number. Okay. So what is this listen thing? Basically, it says a server, right? So think that the DNS server, again, DNS is a UDP server, so let's not think of a telnet server or a FTP server, better still. Think of an FTP server. Okay. Now it doesn't really exactly work like that. We'll show it in the next class. But just think, I have asked for a file download. Okay. So the server is busy giving me the file. So what happens to another client, it wants to download a file and ask the server at the same time. So right now, we are looking at a very simple server which will handle the request one by one. Okay. So question is, so if the second request comes while the first one is being serviced, what happens to the second request? It will just be put in a queue. When the first one finishes, the second one will take it. But then, how long do I want? How many maximum things I want to wait? So this one tells you that. This is telling basically while one client is being serviced by the server, okay, at most 5 other clients can wait in the queue. There's some details that we omit right now, but that's kind of the idea. Okay. If I remember correctly, if you don't make the listen call also, there is a default thing, but always make the listen call. Okay. And now comes the interesting call. So my server is now ready. Okay. So I have bound, I am listening, and so on. Now I'll just show one client connection. So this is still on the server side code that you are writing. Make a call called accept. Okay. Same sock FD. Okay. And then you have same start Serveridia star, Serveridia star and Serveridia. Actually, I'll show you this call. Okay, no point writing. It's slightly something different. I'll explain this to you when it's not very important right now. Okay. Now, so the server has come here, and then the client is waiting for the client, but it doesn't know when the client will come. Okay. The client may come right now. Client may come 5 minutes later. The connection from the client. So what happens? So this is by default a blocking call. Okay, so server waits. So your program will get stuck. Waits for client connection. This is the call that if you understand, you have understood everything more or less. It's a little bit tricky call. Okay, so your program is running here. It comes and gets blocked here. When a client connects, it gets unblocked. Okay. But then this is not the socket now that is connected to this. So TCP sockets, because so TCP sockets are like pipes. This is your server, this is your client. Okay. So when you connect, you are basically creating a pipe. That is why it's reliable, sort of. Okay. How does that happens? Don't worry. And it's in order. It's like a pipe, it's just bite-sized pipes. So sorry. So one bite pushes the other one in front and so on. So it's kind of like that. So nothing can overtake anybody else. Nothing can fall off the pipe. That's why it's reliable and in order. Okay. So this is your client socket. Okay. This was my socket. When it comes out, it creates a new socket automatically and connects this with this. This one stays out there. Why do you think so? Why can't it just could have created the pipe like this only? Anyone? Any guesses? You get my question? This before this
to allow for multiple processors.
What, come again?
Like if we make a connection to one socket, like it can manage the load to other processors.
It's not just load. You're on the right track. Okay, very good. So when I connect this like a pipe, it's only connected to one. Okay, fine. While it is servicing, suppose I had connected to this. Okay, while it is servicing this, others could have come and waited in the queue. Okay, but then when we close it, we'll see just like any other file, we'll close the socket. the socket will disappear. Okay, so we don't want this socket to disappear, and then next class we'll do concurrent connections. Okay, where we'll see. So this is the one that is only for waiting, because this one is what is called a half open socket. We'll explain later on, maybe next class. Okay, but this is the one whose job is to see the connection, create the connection. Okay. So typically when I write this, I'll write the code like this. I'll put a while one, because the server I want to wait indefinitely for client connections, mostly. So what will happen? It gets one connection. SockFD stays intact. Okay. New SockFD gets created. Okay. I'll just write right now. Okay. Let's put a comment. Communicate with client using new socket. Okay. Then close new socket. Don't close socket. So new socket disappears. It's gone. But SockFD is still there. But your code was sequential, so any client coming in has to wait in the listen queue. But then I will go back, okay, we'll come back to this call. See if any client has come in the middle, the accept call will then come out of immediately. So take that connection, create a new SockFD with that client. So with every client, we'll create a new SockFD. That is the one that is communicating with the client. And if there is no other client that's coming in the middle, we'll just wait for the out there for the next client to come. Is this clear? Yes, no?
Yes, sir.
Yes, sir.
Yeah. So slowly we'll demystify this. Okay, but why I wanted to do it this way is like otherwise you look at a lot of code. There are good tutorials. Tutorial will explain how to use this. Okay. But then when we link with theory, we'll see that you need to understand what is happening a little bit at a time. Okay. Okay.
So, sir, one
Yes.
doubt.
Sure.
What's the difference between listen and accept? Like what are they doing?
No, listen is very simple. Listen is just telling you that while one client is being serviced, okay, if other clients try to connect, what will happen to them? They will be put in the queue. Listen is not telling them. Question is maximum how many clients will you put in the queue? So when I say listen 5, SockFD 5, that means while you are doing, so you will communicate, you will do some work here, this is taking some time. So until it comes back to the accept, at most 5 clients can try to connect. From the 6th client onward, the client will start getting a connection refused because 5 of them are waiting. Okay. So listen does not do any actual connection handling. It's a non-blocking simple call to kind of set a configuration parameter. Accept is the blocking call which is waiting for the client to connect. So when we do the client code, this is when the client does a connect call, then this will suddenly come out of the accept call. Is it clear?
Okay. So the client is trying to connect to SockFD, but we're redirecting it to new SockFD. Is that how it works?
Not trying to. Client is connecting to SockFD. Kind of it's like this. Client tells it intention to connect or create a connection to SockFD, and SockFD creates a new SockFD and clients connect. Okay, it's more English words, what you said and what I said. Okay, but the client does not know about new SockFD or anything. Client only knows about this SockFD thing basically. It doesn't even know about SockFD, the IP address and port. Okay.
Yes.
There is an interesting issue out here. Okay, maybe today's class will get too long. Okay, so we'll discuss that later, maybe next class. Okay. Okay, and then this communication in the middle. Okay, we'll use 2 calls. If you want to send something, you send to a SockFD. Okay, you give a buffer, look at it in the code, okay, length, and then right now you put a 0 here. Okay, so this is from where, just a pointer, okay, this is how many bytes. So send basically says put starting from this address this many bytes into the socket. But TCP has some strange properties because it's a byte oriented thing. So we'll talk about that later. But that's what the send does. Okay. So you can do send or you can do receive. You say receive from socketfd. Okay. Where do I want to put it? Again, specify a buffer. This says where to put. Okay. And now I don't know how many bytes have been sent. Okay. So I specify a length which is maximum number of bytes to receive. Okay, and then it's 0. With me?
So why is this not new sockfd and why is it sockfd?
Oh, sorry. No. I'm sorry. My mistake. It's new socket. Sorry.
Okay.
New socket. Yes. Sockfd stays there waiting for just his job is to just to accept connections, create that pipe. That's it. It will always stay half open. Okay. And the exact meaning of half open, this thing I'll talk about. So just remember this. Okay, I will not explain right now. This connection is a 4 tuple. This is a 2 tuple. Each socket. Okay, what the tuple contains, we'll see. So there's a difference between these two sockets. Okay. All right. So then in the send call is fine. You said that okay, starting from this address, maybe this will give the starting address of an array or something. This many bytes you send. But remember, this is number of bytes, not characters or integers or nothing. But you have the size of parameters, so you know how to do bytes. You have done it in malloc and so on. Now this one, so think of now trying to visualize it a little bit. So other party has sent you something. Okay, you are waiting. So this one, what will happen when I make this receive call? Okay, why will this, okay, think of the client server thing. So think of the DNS server. What will it do? It'll first make the receive call because unless it gets a query, it cannot respond. Okay, but then when it makes the receive call, okay, then the other party may not have sent the query yet. So what do you think will happen to if I make the receive call when the other side has not sent anything? So the send receive is now happening through this. If I send something, if you make a receive call here, you will get it. But it's byte oriented, so you may not, if this 100, you may not get in the first call, receive call itself, you may not get 100. You may get less. But then if you got 60, you make another receive call, you will get 20, another receive call, get 20. Any breakup is possible. You may get the entire 100, but you cannot assume that whatever has been sent here, everything will come out in one receive call. But you can assume, or you can know, not assume, you can guarantee that if you make sufficiently many receive calls, everything that has been put here will eventually be received. Okay? But then if you made a receive call and nothing has been sent out, what do you think will happen? Any guesses?
Blocking.
Exactly.
Block.
Okay. So this will block if no data in. So we call it the handwriting is real in socket buffer. Now other party sends some data. This receive call will magically unblock. Okay. Later on, we'll show you how to make this non-blocking. Because see, now this simple server that we are writing, just think of what will happen. Okay. Fine, the connect here, nobody has connected, fine, is ready. But then I've connected with one socket, okay? Okay, this is the other interesting thing, okay? So, yeah, I'll come to that later. Let's not worry about it right now. We'll do that when we do concurrence. Okay, so this is clear, but there's another issue out here. So I said, so remember, this is always remember, this is two machines who do not know about each other. Okay, so I put a receive. I do not know how much the other side is going to send me. Now that also I may have fixed by some protocol. You and I have an agreement that you will always send me 100 bytes. But then, as I told, that TCP will guarantee that those 100 bytes will all arrive to me. But it does not guarantee they will all arrive at once. They'll arrive in order, but the first receive call may give me 60, not 100. So then, but it can give me 50, it can give me 30, or all 100. So the question is, how do I know? I have said maximum how many I want to receive. I know the other side is not going to send me more than 100. I put 100 out there. I allocated a buffer of size 100. But then, how do I know how much did I actually receive? Where do you think I will know that? Any guess?
The return value of receive.
Exactly. Okay. So the return value of the receive call will tell you, okay, what is the actual amount of bit. So ideally, it should never be 0, except for a special case. Okay. Can you guess what that special case is? You get my point? So receive is blocked. It should come out only when it gets some data, which means at least 1 byte, which means the return value should be at least 1. But there is case that may return with 0. Any clue?
Maybe a timeout.
No, it won't time. Okay, good thought, but not time. We'll do that also next class. There's another call by which we can say, we can put this so that it actually times out. But
Sir, connection close.
Exactly. So what if the other side does not want to send me anything? Okay, then I will wait forever. The other party has gone, okay, enjoying life. I am waiting for data to come on this socket. Okay, but that's basically the rules. That's what the protocol is about, the rules of engagement. So if the other side closes this connection socket, which is kind of closing this pipe, then something happens underneath. Again, in theory, we'll see what happens. Okay, to tell this thing that the other side has closed the connection. Okay, it'll drive all the data in front if there is anything undelivered. But eventually, this thing signal will come and this will come out with a 0. So if the receive call ever comes out with a 0, that indicates the other side has closed the connection. Okay. Now remember this, because remember, given that TCP does not guarantee anything about this 100 bytes it will send in what chunks, 50-50, 60-40, 60-30-20, sorry, 60-30-10, whatever. Okay. Somehow you need to, many cases, when you have variable size data, you have to detect the end of the file, that there is no more data. In some cases, this is a good way of detecting it. You send everything, if you don't expect anything back, send everything, close the connection. Other side keeps on reading in a while loop, receiving. When the receive comes back with 0, it knows everything has been read. Is it okay? Am I clear? Yes, no?
Yes, sir.
Yes, sir.
Okay. Anybody know? Okay. So now on the server side, I'm done. Client side is much simpler. Okay. The socket call, same as earlier. Okay. So let's say socket D. Same. I don't wind. Okay. And then the connect call. What is the purpose of the connect call? Tell me, somebody. See what has sunk in. So in the client side, so far based on what we discussed, what is the purpose of the client connect call? Anyone? Take a guess. Take a guess.
So for creating the initial
Not
pipe for exchanging information.
have 3 days.
Right. Okay. So okay. Somebody else was saying something. Go ahead.
Yeah, okay, sir, sure.
Okay. So basically, remember you're on different machine. The server is somewhere else. You are telling your local machine, the local OS, okay, that I want to connect to that node. So to specify that node, that application. How do you specify an application? What did we just learn?
IP address and port.
IP address and port. So any application in the world that is running, any network application in the world, okay, is basically an IP address and a port. If they're running on two different machines, the IP address is going to be different. If they're running on the same machine, same network card, accepting from the same network card, the port will be different. This is how every application in the world, anywhere in the thing, okay, is unique. Because IP addresses, we have a way of, when we discuss IP address, we'll see, we have a way of making IP addresses unique. That makes two machines unique. So two network cards unique to be more precise. And then within one machine, let us take simple case, one network card machine, I will give different ports to different things. So that makes every application this. But this server application like Telnet, FTP, HTTP, web servers, and so on, I will need to, I'll kind of advertise this thing. Some things are this thing that if you do not say anything, your HTTP server will run on port 80. HTTPS will run on port 443. Telnet will run on 21. So these are what are called well-known ports. Well-known, everybody knows them. So they must run on those ports. But anything else, I can design my own server. Somehow it's my job to let all my intended clients to say this is the port that I'm running on this IP address. When we do DNS, I'll say there is a way to specify that also. But somehow at this stage, we just need to know that some of the clients have to. And then the client is saying to the OS by the connect call, I want to connect through this socket. So through this socket, so I specify the socket FD. Okay. How do I specify the IP address and port? Anyone?
The struct.
That same struct. Okay. The exact things we look at the code, and I will point out some more thing. Struct, sorry. Socket DDR star and so on. The same. And that's then you just do this if send. Whatever the thing. You may send first, then receive first, then send, only do sends, whatever. And finally, you close. It's always a good idea to close. Remember, this socket is different from that socket. This is on the client machine, that was on the server machine. Are you with me?
Yes, sir.
Okay. So that's kind of the flow of things. Okay. So to summarize, again, you need to understand the struct server area structure, that's socket area in structure. Kind of memorize that. Okay. Again, you can look up samples and so on. It has three fields: the SYN family, which nowadays we all say AFINET or PFINET, the internet family of protocols, port, and then the address. Okay, no, there is something that I missed here. Okay, they're in the code anyway. So I specified this by this. So what will I put in? Okay, so think about this. So I will say server DDR dot SYN family equal to find. Okay. You can also say PFI server DDR.SYN port. Remember that was running on 20,000. Okay. There's another change. I will do it later on when I show you the code. I'll explain what it is. Let us not do everything at once. But this one, server DDR.SYN DDR.SRDR. If you recall, there we specified in DDR. Okay. But here I don't want to specify. I want to specify that server's IP address. Right? So should I specify, like, just suppose the IP address is 10.5.18.84, 87, whatever. Should I specify this? What do you think? You may not know it, but just break the monotony. Anybody guesses? Do you think this is okay?
It should be. I think it's correct.
Okay. Now again, these are just details. You are not supposed to know it now. So this is basically actually your IP address is a 32-bit IPv4 address integer. Okay. It is just that those 4 byte things we say basically like this, because you cannot remember this 3,597 or something as that, 30,000 something. So this 4 bytes you just specify like this. Okay. Or put the other way, when you assign IP addresses, you assign in this and then the corresponding bit patterns, unsigned integer 8-byte, 1-byte bit patterns you put out there. Okay. So I cannot do this because this is basically a string. It is just the way the thing is written. So we don't do this. There are functions given to us. INET A to N, and you say, I forgot the syntax. I think it's the first one in this string, and then you say and server DDR dot SYN DDR dot S. So it is just the function. It says ASCII to network. So network is basically, so this will convert that to 32-bit integer and assign it to the field of the space. I may be slightly wrong in the syntaxes here and there, but that's not important. There is also a function P2N. For the simple, this is okay. Both are okay, but they have some differences. But let's stick with one. Is it clear? So the flow of things for TCP server is socket, where you specify this family and 0 is constant, the middle one string for stream sockets. Okay. Then you bind, then you listen, then you accept, and then do send listen. On the client, you do socket, then you connect, then you receive send, then you close this everywhere. Okay. No bind, but you can do bind. I'll discuss what happens when you do bind. Okay. But normally, that does not mean that every socket must have a port associated with it. So you are not binding it in IP address port doesn't mean this socket does not have an IP address port. It is just that you are telling the system when you first time use the socket with this connect call, is telling the system, I'm using it for the first time. I don't care what my IP address and port are, because I don't need anybody, nobody needs to connect with me directly without knowing anything. So please give me something that is not used. Obviously, 2 applications cannot use the same port on the same machine, because then there will be confusion. So the system looks up an unused port, assigns it. IP address is the network card's IP address, and when it sends the packet to the other side, the server will get this IP address port. So it now can send a packet saying, "Oh, send this packet to that IP address port." Is the port that the assigned to the client by the client's local machine. Is it clear?
Yes, sir.
Again, it's not for your basic mechanical programming, it's not important. You don't need to bind. I'm just saying, but we need to know that every socket will have an IP address and port. Either you bind it or the system assigns it for you when you use the first time. In server, you always bind it. Client, you have the option of binding it, or the system will do it the first time you connect to a server. Okay. What about UDP server? Even simpler, mostly simpler. You do socket, you do the same bind, but the UDP server, you don't do any accept or anything because there is no connection. So in a UDP server, okay, this is an UDP server and UDP client. Okay, so UDP server can connect with UDP client. So there is nothing, no connection to be made, no pipes or anything. So it says send to this, it goes in. It can get dropped, it can get lost. Two of them can overtake each other, anything, but the network will find its way, and if it finds its way up here, it will pop out. But it's one message at a time. Whatever is sent together will be popping out together, unlike TCP. So there is no, kind of pipes or anything made. There is no reliability guaranteed, no in-order delivery guaranteed. So there is no need to accept or wait for any connection. You bind because you want to tell the system this is where I'm waiting, because my clients expect me to bind to this. So DNS servers, clients expect you to come the DNS servers port. I forgot what it is, 60 something, forgot. Okay. So you bind and then you can do send receive, but then, okay, I'll come to the send receive. What about the UDP client? Simpler, socket. No need to bind. Okay, you can, but no need to bind and no need to connect because you're not trying to establish any connect. Okay, but then there is no need to connect. Okay, then no, where am I specifying? If I just do a receive send now, okay, then where am I specifying who is this packet supposed to go to? I'm just doing a socket, then I'm doing a send. For TCP, when I did a connect, the system remembered that this socket is connected to the other end like this IP address. So every time I send, it is actually saying, oh, this socket is connected to that server IP address port. So therefore, this packet will have to go to this. But here I don't do this. Okay. So to do some extra work, we'll see. Rather than send, I do send to. And then first 4 fields are exactly the same as send. And in the next 2 fields, I say who to send to. And similarly, there is a call called receive from. We'll just be cutting the code. Same thing, first 4 fields are the same. Okay. And then not exactly the same. Oh, sorry. And this will be the client who sent. So now you see there is no new socket, no different. This is one socket, one socket. You see by changing this, using the same UDP client socket, I can send to multiple UDP servers. Okay. Similarly, the UDP server doesn't care. That is server anyway doesn't care. It can receive from multiple clients, of course, just like anywhere. But unlike the thing, there when that socket got connected, I can only send to that server. And that socket in that server, nothing else. Whereas in UDP client, because in every call, I'm specifying who to send to and so on, I can use it to send to multiple UDP servers. But then when you start programming, you will see that there are issues out there if you want to do a long conversation between them. Basically. But then we'll see that in program. Is it okay so far? If so, then we'll go to the code.
Sir, in the receive from function, how will we expect that the server knows from where will it be receiving information?
No. See, even in the TCP server, when it is waiting at the accept call, it does not know who will connect. Right? What will happen in the accept call? I will show it in the code. There's parts of the script here. That when the client connects, there are parameters, input-output parameters in the server, accept call, which will tell the server who has connected, whose connection did I accept. Okay. Now that even there is not important because underneath the new socket will already store that address. So you just send something to new socket, it will go to that client. Okay. I'll explain that more in the code. Here, the UDP server is just waiting. So UDP server will get anybody sends to a UDP server, it will just come there. It'll still be a blocking call. Okay. So it'll wait there, but when it comes back, these two parameters will tell it which is the client that connected, that sent that not connected. I'm sorry, connected is the wrong word here. Which is the client which sent this particular message that I just received, which let me come on. One message at a time. Okay. And now if it wants to send to that client, it can use this address in the send to call to send to that. Does it make sense?
Yes, sir. So like I guess they are like empty pointers in the beginning which get filled with the necessary information.
Right. Exactly. When you see the code, I did not write that much because again, more start socket here starts things. Okay. But it will pass basically a place for it to put the client address. The client address will pop up when this comes out of the thing. I read that, put that in the send to send it basically. Okay. Any other questions before we go to code? I warned you, it's a long class, I know. But I think let us not take a break, okay? It'll take probably another half an hour or so. But let's keep the continuity. Is that okay? Yes, no?
Yes, sir.
Nobody wants to say yes here. No? The rest of the class may kill him or her. Okay. Let me keep my great handwriting this time anyway. Wow. Okay, let me just save it. Oh, I can save it there only. Just a blank board. Okay. So let's see what I have here. I opened too many things. Okay, it's all here. So there's a lot of comments. So these are sample files we'll give you. We'll give you at the end of the day today. Okay. So this is my TCP server. There's a lot of header files you have to include. Just have to remember them. Okay. Otherwise, an easy thing is that see all these things are for your socket and all those calls. So I think all of you know the man pages in Linux, man something. So just to man socket, man bind, tell you what's header files mean. Okay. So I declared this two socket descriptors that I will need for the server, socket FD, new socket FD. Okay. And I declared these two structures of type socket arena and a single client length variable. Okay. Why two of them? We'll see. We could have used one, but let's see. And I have a character buffer. All I'm doing in this thing is just sending one message from the server to the client. I think. Let's see. That's so. I will come to it. No worry. Okay. So this is my socket call. Okay. Always check for errors. So all these calls, if they fail, returns you -1. Okay. So 0 is not error. As I told you, like the receive call 0 is not error, for example. Okay. And then I don't know how many of you know about this p error function. Okay. So the way Linux works or Unix-like system works, there is a variable called error number, ERRN. It's a global variable. Okay. And any system call that you make, socket, whatever you're calling, if there is an error, the call will return -1, but then -1 can be, the error can be for many things. You need some help as to what the error is. So that error number value is set to a certain value. And that each of those values has a corresponding string with it. If you just print out the error number variable, okay, you will see the error number variable, but then that's not help. Then you have to look at the file error number.h to figure out. So p error is a function, okay, where you can add your own comments, message, and then with a colon, I forgot the front or back, it tells you what that string is. So for example, bind, will say cannot bind address in use. So you have specified cannot bind. The address in use part will come from the error. Okay. So simple way, when I give you the sample code, simple way to check this p error if you don't know it, just make a mistake here. Okay. Make a spelling mistake here instead of sock stream and see what happens. You don't find the type, it will give you an error. Okay, and do that. Okay, one thing I forgot to mention during that thing, for the UDP socket, this will be sock dgram, DGRAM. Okay, that's the thing. Okay, so now I have the sock ADDR in structure server ADDR. I fill it AFI net, scenario ADDR, etc. And then here, see, this is the extra thing I was telling you. I do an H2NS. Anyone knows what it is? You're not supposed to. Okay, but you have gone through an architecture course. Okay, remember now, a simple, my Linux PC can correspond with a Windows machine. Okay, the server may be running on Windows, the client may be running on Linux. Server may be a IBM PowerPC. The way this thing may be a Dell Xeon server. So there can be many differences in things. Okay, so you know about little endian and big endian? Yes, no?
Yes, sir.
Yes, right? So what will happen? So think about a 4-byte integer. Okay, 1, 2, 3, 4. That's my integer. Okay, so then in some order, these 4 bytes will go on the where. Now 4 is my least significant byte. Let's say I send it in that order, least significant byte. So basically what has gone in, first 4 has gone, then 3 has gone, then 2 has gone, then 1 has gone. So that is what is gone in the where. So other side receives it in that order. Okay. But then if the other side follows a different integer representation, I always forget which one is little, which one is big. I think the first one I said is little. Okay. But anyway, that's not important. Then it may interpret 4 as the most significant byte, 3 as the least significant, 2 as the one this. Okay. Because it does not know what the other side, what is the client machine is. So it does not know whether the client machine was little endian and sent in that order, or it was big endian and sent in that other order. Okay. So there is something called a network byte order. It's kind of a standard. It says whatever your integer format is, okay, when you put on the where, you put it like this order. That you will put always less significant byte than this. So then the other side knows if it's in network byte order, it's got 1, 2, 3, 4. It says irrespective of how the client machine stored it, 4 is the least significant byte. And therefore, depending on its representation, it will say. So H2NS stands for host to network short. It's short because in port I have said is 16 bits. This is short, unsigned short actually, not an int. Okay. Similarly, for 4 bytes, you have an H2NL, host to network long. So before you put on the port, okay, because this is something that will go on the where and will be interpreted as an integer, you just convert that. Okay. Then we have the bind. So socket, you will not get too many errors, okay, unless you have created like huge amount of sockets. Bind is very common to get an error. I'll explain to you why when I run the code. Okay. So this is, as I said, struct socket area star and server area. Okay, and you do size of server area. Then again you do a p-error. If there's an error, you print the error message, you exit. So this, as I said. Listen is also simple. Okay. Okay. Here is the socketd, the accept call. While one, these lines are kind of what I want to focus on. So the second line is the accept call. Socketd, as I said, struct socket area star and CLI area, and you pass an output parameter, the CLI lane ampersand CLI lane. So what will happen is when the connect call is made, okay, will come out of the connection, new socket will be connected to that, and this field will be filled up with the size, the address of the client, and this field will be filled up with the size of the struct socket area system. Okay, so you will know which is the client that connected to it. Okay, and you note one thing, that it's not that you need to put a line, you need to actually, this actually input output parameter, the CLI lane. You actually put the size of it. So it is telling this thing that the amount, this pointer, I have put a structure of this size, and then the other side fills that in with the structure that came in. Okay. Just do it like this now. Okay, so have this line. Don't just think that if I pass ampersand, it gets filled up. If you don't have this line, you will get strange errors sometimes, so strange results. Okay. I'll explain this more later. But then my question is, why do I need to do this? Because the new socketd, okay. So if I put a 0, 0 here, would it work? 0 here, 0 here. That is null pointers. What do you think? Would the server and client be able to communicate? Yes, no? Anyone? Who's guess maro yaar? Think of it as an MCQ question. Will you be able to communicate?
No, sir.
Yes. See, this is because your connection information is ingrained into new socket. Okay. So this has nothing to do with the actual communication. This is just giving you additional information to say, I have set up a connection. Okay. Now if you put something in new socket, it will go to the other side. No issues. But this is the client who is connected. Why do I need it? It's up to you whether you need it or not. One example, for example, if I say I want to block those 5 IPs, I don't want anybody to connect from there. But I can't, I have to make this accept call for the other clients. Okay. So there are other ways of blocking it, but the simple way is, then if they make the client call, so I just check this address right after this, okay, to see if one of those 5 addresses. If so, without doing anything, I just close the connection. So it's up to you whether you want to use it. It's just giving you an additional piece of information that this is the client who has connected to. Okay. But your main communication between the server and the client is not blocked by this. Okay. And this is now a simple thing. I just send a message to the client. So a string copied message from server. Also send the \0. Okay, then I wait for the thing, assume that more than 100, and whatever has come, I have assumed that that's the protocol between client and server, that the client will send with a \0 at the end. Okay, I print it, I close the socket. Okay, so that's my server. My client is pretty simple, just a socket, no bind. Okay, so I do the same thing, I make the connect call. So this parameter thing, but this is the INET A2N I was telling you about. Okay, sorry, no SREDR. So and server area.simulated. So you just put it in that structure. And this 127.0.0.1 is a special address for the local interface. So usually you will test your programs by running the client and server on the same thing. Okay. So you'll suit the 127. But then if you do it on some other machine that your server is running, you need to come to your code and change it here. Alternatively, you can do many things. You can write a nice client which takes that as a command line argument or something. There's a lot of comment out here. You can read that later on. And now that it's connected, it's waiting for this. So this message from server will get printed, then it sends the other one. Again, that's the agreement. So it sends the +1 also. Okay. If you forget this, then the \0 is not sent. And then the other side tries to print it with percentages, it will get an error. So that's your TCP client. UDP server, similarly, as I said, only thing is you have a sock dgram here instead of sock stream. Okay. And this ones I think we did there also. This is good to zero out the server address on this. So bind is exactly the same. Okay. And this is the receive from call. So it basically says this, whatever you receive, start putting from here. Maximum size that I can receive is this. So but remember this message oriented. If you have specified in a TCP case in the receive, you have specified 50, okay, and 100 has come, you'll get the first 50, the other 50 will stay there. But here, if you have specified 50 and the 100 has come, the 50 will be dropped because it's on, through UDP, it's on one message. Either you take it or I drop it. And this is where it will tell what the address is. Okay, I should have actually added something to send back, but okay, that can be done easily later. Okay, and finally the UDP client. Again, you do sock dgram here. No connect, nothing needed. And send to, I fill up the same server reader field. So now send to, here is where I want to send from. How much? This much. These first 4 fields are same as send. And this is the one that I'm telling that send to this server. Okay. Again, this is slightly, yeah, it's a send telling basically inherit is kind of may not be the good thing here. You should actually specify 127.0.0.1 the same way. Just took a shortcut. Okay. So any questions so far? I know it's a long class, but we're going to look at the code now. Let me see. The codes are still there. Disconnected. Okay. So I have to connect it again.
Sir, putting in ADR any while sending, what will be the expected behavior?
Well, like that, see, because I kind of assumed it's going to be all running the same machine. Okay. So it's basically saying that whoever is waiting for it, give it basically in the same machine. Okay. But truly speaking, when you connect, you should specify the IP address. Even if it's local machine, you should specify 127.0.0.1. Server can say in ADI. The server is saying that whichever interface the packet comes through, I want to get it. If it is for my port. So that was more, I would not say a mistake, but not a good thing to do for me. Okay. So I've got these 2 windows. So I'm going to run the TCP server. So this is my TCP server. I've already compiled it. Just standard CC, nothing. So, but let me do one thing. So let me first find the client. What is it? TCP, so /. See, why does this say unable to connect to server? Connection refused. Trivial reason.
Port in use?
No, because I have not run the server.
Okay, sorry. I
There is no
thought
server.
you were
Okay.
trying to run this
Yeah,
server.
that's why I wanted to run this one. Okay. Because see, the server has to be running for the client to connect. Otherwise, there's nothing to connect. So let me run the server. And if you get nothing, is basically it's waiting at that accept call. It has done, it has bound everything, no errors, nothing. Otherwise, it would have come out. But it's waiting at the accept call out there. So now I run the client. You see, so this message from server came from the server, message from client came there. So this server printed the thing and then went on in the while one loop to wait for the next client. If I do this, this will happen again. Every time I connect, this will happen. Client's job is done, so client just goes. So this is an infinite loop now. You want to kill it, you need to do controls. So let me run the UDP server, or let me show you something. Or okay, let's do this. What happens if I run two servers? Okay. So this one is running. This one is waiting at the thing. Okay. It says unable to bind local address already in use. So this unable to bind local address thing is the message that I put in the peer. And this address is telling me what the reason is, because I did not know. I just knew that bind has failed. But this p error reads the error number variable automatically, looks up the corresponding string in error number.h, okay, and says the address already in use. I'm not sure where this. Okay, will not. I'll show it to you tomorrow. Next class, basically, where it is, which directory. Okay. So now, if you run the client, they can of course the same thing. Look at the UDP code. Same thing here. If I run the client first, now you see, okay, what happens if I run the UDP server now? A bit different. What happened to this message? Okay. See, now you should see the difference. Now there's something else come. So you see, when you in TCP will see there is an exchange to make that connection. Here there is no connection really. The client is just from the client machine, the message has gone out in the network saying send it to this. And it has come all the way to this machine. But then it found there is nothing running at that port number, so it just silently dropped it. But the client does not give any intimation or anything. It's not reliable. So the client should wait for some time out, and then just send it. But this one has come. But there's no guarantee this could have also been lost. It's the same machine, so there is almost no chance of getting dropped. So this one sent from the client, and then the server printed it. There was nothing coming back from the other side. Actually, probably I should have added. Well, you can look it up also. Online code to send something back to how to use that client address. So just like inet A to N, there is another function called inet N to A. We will convert from the standard form to the string form basically. So you can print that string out to see which IP address the client is connecting from. And the port is port. Is it okay? Yes, no?
Yes.
Okay.
Yes,
sir.
sir.
So the last thing we do is to just show you what you have to do next week. So this is your assignment. So end of this class, I'll put up all these things in my website. I'll write down the website for you. Send you a mail. I'll send you a mail. And also there is a common Moodle submission page for this. So the assignment will be up in Moodle also. Okay. So here is what you will do. So this type of servers that we just looked at, which handles clients one by one. Okay. Because you did create another socket, new socket, but then there is the same execution branch. Okay, same one processor. So you don't really, nothing happens until this iterative client finishes. It's called iterative. It finishes with one client, then goes to service the next client, basically. But you have the while one loop, so that automatically goes to client service the next one. So here is what you have to do. The client will send a text file to the server. Server will count the number of sentences, words, and characters and send them back to the client. Okay, and then client will display it. But there are some subtle issues out there. So you open a TCP socket. The client will read the name of a text file as a command line argument. Look for the file in the local directory. Two possibilities: it's there or not there. Not there, if it's an error, no, everything exits. So nothing happens to the program. If it is found, then you execute the thing. Okay. And then you have to read the file name into a buffer, so you can assume maximum 100 characters. So just to straight, no hassles there. Then you establish the connection. Then you read the content, send it to the thing. But obviously the file can be arbitrarily long. So the client cannot send the entire file in a single send call. So it decides to send 100 bytes, 50 bytes, whatever, some chunk size, and send it one by one. But this chunk size is not known to the server. You cannot assume that if the client sends it 50, the server knows it 50. All you can assume is here that the maximum that will be is 100. So the server basically knows the client will not send more than 100 in a single chunk. Okay. But the server does not know what exactly the chunk size is. Okay. And then it receives the file, compute, sends this thing. One thing will get added here. So the server cannot write the file. Write whatever is received into another file. It looks at the buffer. End of sentence is full stop. We have told that very clearly. I've told you how to read at the end of file also. So there's some boundary cases you have to take care of. But that code is like any other code. You're in third year now. That code is like reading from file and counting this thing. It's just instead of data coming from the file, it's coming from the socket. Okay. So this is the thing, important thing. So you have to count sentences. Sentence will be terminated with a full stop character. And you can assume that the full stop character does not come anywhere else. Okay, so there will the name of the file is zeroed out. That will not happen. Okay, because that will throw your count thing off. Okay. And you can assume that any sentence has at least one character which is not a full stop. I'll come to this why this is important. As I said, you can assume that 100 bytes maximum, but you do not know what the exact chunk is. Can you hear me? Yes, no?
Yes, sir.
Okay. Okay, you cannot do this. You cannot send a priori the server side. This client just starts sending the file contents. Okay, and read up these calls. You will read it in OS a lot. We don't want you to use fopen, scan, as fprintf. You're doing byte level things. You should use open read. Fopen actually calls open, fscanf calls read, fprintf calls write. So they are very similar to the send receive calls that you have done. Only the last parameter is not there. So read will say where to read from. You'll have a file descriptor which will be given by open. Okay, then where to put the file, how many bytes and so on. So just take a look at the man page of this, you will understand this. But don't open fopen, scanf, don't use them. And this is a submission instruction and all. So this line is important because just think with me. I know it's a long class, but it's kind of near the end. So think with me for a second. Okay. So the server is waiting. The client is sending chunks. Okay. First of all, the server does not know whether the client is going to send 50 at a time or 30 at a time or something. It just knows it's not sending more than 100. Okay. So how does the server know? Okay, what is the end of the file? When is the end of the file? So suppose it has got a full stop, and then nothing else. Then maybe 10 blanks, nothing else. But the blanks can be there anywhere in the file. So how does it know that nothing more is going to come? Now, as I said, if the server did not have to send anything to the client, they could have agreed on something that the client, after sending everything, will close the connection. The server is waiting on the receive. It has got everything that has been sent so far, okay, and then it's waiting on the receive for something more. But then if the client has already sent the entire thing, how does it know? How will the server know? So we use a very age-old idea. We say put a sentinel. That means something that cannot happen in the valid input. So this line is given to you for that. So if the server detects two full stops, okay, which is not one after the other with no blank in between or anything, that indicates is the end of the file. Because any other sentence will have at least one character, maybe blank, but at least one character. So after you want to transmit everything, transmit two blanks or two full stops or something, which indicates basically to the other end, that's the end of the file. Then it processes the thing. It has kept a running count of words and all. You know how to do it. It's a little bit of coding, but it's okay. So that's the assignment. And then the next part, you will have to do the same thing, okay? But you have to do an iterative UDP server. Now here it's not a problem because both sides know maximum 100, so I can wait to receive 100. If I receive 50, that means the server has UDP server has sent me 50. Okay. There is a catch here, okay, and you can ignore that. Okay, I'll modify this assignment a little bit. That the UDP is not reliable. Okay, so you can assume that it's a local machine. It will be most reliable. So if anything gets lost, it gets lost basically. But there is a catch there. What if the double dots get lost? So in retrospect, that's not a good thing to ask you to do. I'll talk to the other teacher to see whether we want to drop that. Okay. Or just change it slightly. So I'm done. Okay. Thank you for the time. So first of all, right now, do you have any questions? How many of you are there?
Sir, is this a group assignment?
No, this is an individual assignment. Because we'll give you sample codes and everything. So connections and everything, almost everything you have is just looking at that thing and so on. So first couple of assignments we were. So everybody must exercise the socket calls on their own, hopefully. So this will be 1 week, this assignment. Let's see how it goes. Has your OS assignment started? When is your OS lab? Which day of the week?
Tomorrow it will start.
Tomorrow it will start. Okay. Any other questions? Somebody else send a chat. Don't send me chat in the middle because I cannot look at it anyway. I don't know what the chat is. Any other questions? Okay, otherwise the meeting will stay open. I'll be here for another, let's say till 4:30. Okay. I'll stop recording and not share the screen. But the meeting is open. So if you have any questions, I'm here till 4:30. My suggestion is to take a look at the assignment. Okay. The UDP one you ignore. I'll talk to him to see. Because even though 99% chance, or do it, let's do it. Okay. So ignore the error and do it. Because if most of you are going to test on your local machine, nothing will get lost. That's one problem with this course basically. But that's okay. how we do things. That's it. So UDP1, be on the lookout. I may add a few lines to see. So again, I will send you a mail right shortly with the site name and everything, Moodle joining code. I have not given you the Moodle joining code, right? Yes, no?
No, sir.
No, sir,
No.
not yet.
No, not yet. I'll send it to you today. Okay. So then, so if you don't want to be here, you can go.